Week 23, Pure Maths 1, Maintenance, Quadratics question. We've got an inequality. Probably I will just expand the left-hand side to get x squared plus the 10x. And then I'll bring that 12 across and that negative x across by subtracting and adding them. And I'll get this. Now I gather together my like terms, so I'm getting x squared plus 11x minus 12 is less than or equal to 0. And then, well, I think we can factorize this. So I've got x plus 12, bracket x minus 1, less than or equal to 0. And so if we were to sketch this, we've got a root at 1 and a root at negative 12. And we want, where is it less than or equal to 0? So it's between those two values, so minus 12 and 1. So I would write this as negative 12 is less than or equal to x is less than or equal to 1, and that would be my final answer there. Next one, I'm trying to write this in a completed square version, so we're getting quite good at this now. We've had so much practice. I would first factorize out that 2. Do my square brackets here. I'll leave that 13 outside of the square brackets now. At this point I'm going to complete the square within the square brackets. Subtract 9, and then I've got the plus 13. Then I expand, so I get 2 into x minus 3 all squared minus 18 plus 13, and this leads us to a final answer of 2 bracket x minus 3 all squared minus 5. So next bit is the function is defined. So we've got the same function, but for x is greater than or equal to k, where k is a constant, and it's a one-to-one constant. Okay, so if I was to sketch what I just drew, this one here, you know that you've got a minimum point at 3, negative 5. And so therefore, if we want it to be a one-to-one function, we can't go any further than that minimum point. We can't go any lower than that. So x is greater than or equal to k, and k can't go any lower than that if you want it to be one-to-one, because as soon as you go past the minimum point, you're going to get a many-to-one, like this point and this point are, say, equal. So what I would say then is k is equal to 3 at the minimum point. Now, well, that was rather easy, wasn't it? Cool. The points of intersection on the for the line and the circle. Okay, we've got to find them. So, okay, well, if that's what y, if the line is equal to y equals x minus 3, then y. No, yep, that's fine. So what I'll probably do is I'll just pop this into the values of y here. So for the circle, I'm going to get x minus 3. All squared plus, and then I go x minus 3 plus 2 all squared equals 20. So you can see I get x squared minus 6x plus 9, and this ends up being x minus 1. So for that I'd get x squared minus 2x plus 1. And I'll bring that minus 20 across and I get equals to 0. Now let's gather all of our like terms. So we get 2x squared, we get negative 8x, and we get 10 minus 10, I think, equals 0. Now I'm going to divide by 2, so I get x squared minus 4x minus 5 equals 0. So x minus 5, x plus 1 equals 0. So we've got two values that x can be. X is either equal to 5 or negative 1. And therefore y will equal to, and I'm going to pop those x values into here to find my y value. So if I pop the 5, and 5 minus 3 is 2. If I pop the minus 1, and minus 1 minus 3 is minus 4. So the 2 points of intersection are at 5, 2, and negative 1, negative 4 are our points of intersection. Oakley dokley, moving on to the circular measure question. In this diagram, OAB is a sector of circle with the radius 8. Angle BOA is a radians. OAC is a semicircle with a diameter of OA, and the area of the semicircle is twice, that's important, the area of the semicircle OAC is twice the area of sector OAB. Find alpha in terms of pi. Okay, well, the area of the semicircle is half r squared theta, so that is, so this blue bit here is half times 4 squared times, now theta is pi in this case. Now we know that the area of the semicircle is twice the area of this top bit here. So this top bit here is 1 half r squared, so 8 squared in this case, times theta, which is alpha. Okie dokie. So on the one side here we've got 8 pi equals, and on the other side we've got 64 alpha, and therefore alpha equals 1 over 8, so 8 over 64, which is 1/8 pi. There we go. Find the perimeter of the complete figure in terms of pi. Okay, so if we're thinking now about the perimeter, so we've got this bit here, which is 8, right? That bit there is 8. Plus, and then we've got this bit here, which is an arc length. Now arc length is r theta. So I guess here it's just going to be r times alpha. And we've already found out what alpha is. So r, now what's r? R is 8. So 8 times 1/8 pi. And then the last bit that we've got is this bit here, which is r theta. And r in this case is 4. And then theta is pi. So if we pop that all together, we're getting 4 pi plus 5, I think it's 8 plus 5 pi all together. Well, that was rather easier than I was expecting. Okay, so we've got a trigonometry identity question. Let's see how we can go with this. What are we trying to prove here? Ugh. Okay, right, so we're going to cross multiply. So in the next line, I'm going to have sine, bracket, sine theta minus cos theta, plus cos theta into sine theta plus cos theta, and then this is all going to be over sine theta plus cos theta, bracket, into sine theta minus cos theta. Now let's concentrate on the top. We'll get sine squared theta minus sine theta cos theta plus sine theta cos theta plus cos squared theta. That's the top. Now the bottom we're going to have sine squared theta, there should be a bracket there, minus sine theta cos theta plus sine theta cos theta minus cos squared theta. Now at this point on the top you can see that this and this cancel out, on the bottom this and this cancel out, and we've got sine squared theta plus cosine squared theta on the top, and then on the bottom we've got sine squared theta minus cosine squared theta. And so on the top we've got 1 because sine squared theta plus cosine squared theta is 1. And then on the bottom we just leave it as sine squared theta minus cosine squared theta. Hence, solve the equation. Okay, so we're just going to go 1 over sine squared theta minus cos squared theta equals 3. We bring everything across, so we get 1 into 3 sine squared theta minus 3 cos squared theta. I'm going to get everything into sines. So not cos squared theta, that'll be 1 minus sine squared theta. So I've replaced the cos squared theta with a 1 minus sine squared theta. Next line, so 3 sine squared theta minus 3 plus 3 sine squared theta. So we get 4 equals 6 sine squared theta. So sine squared theta equals 4 over 6 or 3 over 4. And therefore, oh, what? 4 over 6, sorry. Hang on, 4 over 6? What am I thinking? 4 over 6 is 2/3, isn't it? Okay. So then I'll take the square root of each side. So sine theta is equal to plus or minus the square root of 2/3. And theta is equal to the inverse sine of plus or minus the square root of 2/3. Okay, now, if we do, now what are we in here? We need to be in degrees, so set your calculator to degrees if you don't already have it to degrees. Inverse sine square root 2/3. This one is giving me 54.7. And then that's our principal value for that one. And then of course we'll have negative 54.7 for the other one. Now let's just so we've got one here, one here, we've got one here, and we should have another 2 there. So to get to this one we just add 360. So that gives us 305.7. And then this one we're just going to add 54.7 to 180. So it should be 234.7. And then this one here is going to be 180 minus 54.7. So it should be 125.3. I think that's all good. Yeah, I think that should be fine. Alright, and there we go, moving on. The third term of geometric progression is negative 108. Okay, so that's AR squared equals negative 108. The sixth term, which would be AR to the 5 equals 32. Find the common ratio. So we go AR to the 5 over AR squared equals R cubed equals 32 over negative 108. So therefore R equals the cube root of that. So we go cube root 32 over negative 108, which is giving us negative 2/3. So therefore R equals negative 2/3. That's our common ratio. Therefore the first term, well, we can just substitute in A times negative 2 over 3 squared equals negative 108. Therefore, A equals, and we go negative 108 divided by negative 2/3 squared. And that's giving me negative 243. Now the sum to infinity you'll have in your formula sheet, so it'll give you what you need to do here. So it's A over 1 minus R, and in this case it's negative 243 over 1 minus 2/3. And if we chuck this into a calculator, and that would be 1 plus 2 over 3. So it should give us negative 121. Hang on. Let me just get this right. 243 over 1 minus 2 over 3. Negative 145.8, I think. Now the last one is a differentiation question. We've got a point moving along the curve in a way that the x-coordinate is increasing at a rate of 0.015 units per second. Find the rate that the y-coordinate is changing when x equals 2, stating whether the y-coordinate is increasing or decreasing. Okay, so the x-coordinate, the rate that it is moving, is dx dt, right? So that's equal to 0.015. I know that dy dx from here is equal to 3 minus 6x squared. And I'm trying to find the rate that the y coordinate is increasing. I want dy dt. Now I can see that that's dy dx times dx dt, because that will cancel out. So I should have 0.015 into 3 minus 6x squared equals 0.0, what is that? 3 times 0.015, which is 0.045. Whoops, write neatly, please. And then 0.015 times 6. So this will give me 0.09 times x squared. Now, at x equals 2, which is what we've got here, dy dt equals 0.045 minus 0.09 times 2 squared equals, now let's just chuck that in, negative 0.315, and therefore, because it's a negative, y coordinate is decreasing. And that is us for the day. Well, I hope that's been helpful to you, team. Let me know if there's any errors or questions you have about this. Take care. God bless.